So here we go, just moving the mouse around, and it's entering text there. Again, this is visible, but it could be in a hidden iframe, and you'd be filling in fields in a form on another site. Actually, in Firefox, this does go a bit crazy, and it will work up there as well. Yeah, that's... okay. So that technique I just showed you, it's called Formspring. So instead of requiring a click for each field we want to fill in, we can actually just fill in lots of fields in one go. Now, the details of this vary between various browsers. In some browsers, you have to move the mouse between each drop. For example, that's the case with Chrome. So actually carrying out this attack may be a little tricky, but it's definitely possible. This also does work on Macs with the default Java runtime there, but it doesn't work on Linux. On Linux, you actually still have to do a real drag and drop moving the mouse for this to work. Okay, so that was techniques for injecting data into a web page and extracting data from a web page. So all of those, like normal clickjacking, require user interaction to work. I'm going to show you something a little different here, and this is something which I actually discovered during the course of preparing this presentation. And it allows us to get some information out of a frame automatically. Now, you remember at the start of the presentation, I said that the same origin policy prevents one site from accessing the content of a framed page. Now, that's not entirely true. So, if you think back to near the start of the presentation, I mentioned the fragment positioning method. That was using IDs in a page and using the fragment identifier at the end of the URL to make the iframe scroll to a particular element without knowing exactly where it was on the page. Now, clickjacking uses nested iframes. So we've got an inner iframe that has a particular site in, and then we have the outer iframe that's cropping it and positioning it on a page. Now, with the fragment positioning, what happens when you load a URL with a fragment on it is that the browser will scroll the iframe to make that particular element visible. Now, we've got the two iframes, and what the browser actually does is scroll the outer iframe, and that's controlled by the attacker. And because for that reason, we can actually read back the scroll position of the iframe and detect the position of a particular element on a web page. So this is how it's done. We load a page in the iframe. We make it very small. We navigate to a particular URL and include a fragment at the end of an ID that we know might be in the page. And we can then read the scroll position of the iframe to tell whether or not it's in the page and also the position of it on the page. Now, what use is this actually? There's been various research to determine from a browser whether or not the user is logged into a particular site. This is useful for something like clickjacking because it requires user interaction. Now, let's say someone was trying to target a user's webmail account. The user might use Gmail, they might use Yahoo, they might use Hotmail. Now, because a clickjacking attack requires user interaction, we don't want to target a site that they're not logged into, that they're not using. So if we can tell whether they're logged into a particular site, that could potentially be very useful. There's various current techniques that try and do this using methods such as seeing if a particular page is cached in the browser, and also things like trying to load an authenticated image. If you're authenticated, the image will load. If it's not, it won't load. Now, those techniques, they do work, but it's very different how it works for each site. This method can be used in a very large range of sites because nearly every web page has an ID in it. So these are the kind of things we can do with this. At the most basic, we can do login detection. So we can tell whether a user is logged on to a particular web application. So we can say, okay, let's load an authenticator page in the iframe. And if you're logged in, that page will load. If you're not, it will probably redirect to a login page. So we can pick an ID on the page, and on the authenticator page, and we can say, is this ID present in the page? And if it is, then the user's logged in. If it's not, then they're not. Now, we're not just checking, with this technique, we can tell not only that a particular element with a particular ID is on a page, we can also tell its position on the page, because we can read the scroll position. So we can do more interesting things as well. So, for example, if there's a footer on the page that has an ID, we can load a page and tell how far down the page that footer is. So if the page is variable length, we can tell things like how many emails are in the user's inbox and various things. So there are many applications to this beyond clickjacking. I'm sure people will come up with interesting things that can be done with this. I'll just quickly show you how that could work. Okay, so this is a page. This is copied. This is a copy of a page, an offline copy of the Gmail inbox as would appear in a Google gadget. Now, there's various IDs on this page, and we can detect various things. So here we go. When I've loaded this page, you can see a little tiny iframe up here, and that's got that page in it. And by trying to navigate to particular IDs, it can tell various things. So, for example, there's an ID on the page called current label, and we could use that to detect if the user is logged in or not. Also, each message down here has an ID like this, so checkbox 0, checkbox 1, and we can actually detect how many emails are in the inbox. And here you can see it's also read the position of a particular ID that's at the bottom of a page. Oops. Okay, so that was some new clickjacking techniques. Perhaps the most important thing is how sites can protect against these attacks. So at the moment, there are two ways to protect a site from clickjacking. The first is to use something called XFrame Options, and this was introduced by Microsoft in Internet Explorer 8, and various other browsers have implemented this as well. And what this says is it's an HTTP header, and if a site sets this header, it basically says, do not allow my site to be included in an iframe. And you can see here, this is what happens in Internet Explorer if you try and load a site in an iframe that has this header set. Now, this is probably the best method to protect against clickjacking, but unfortunately, older browsers don't support this, and also Firefox doesn't yet support it. They're working on it, but it's not there yet. So to protect users who use those other browsers, we have to use JavaScript. Now, there's two main ways to use JavaScript to prevent clickjacking. The first is to use frame busting. What that is a site will say, if I'm framed, then break out of the frame, and it will replace the page that's framing it. The other thing you can do is, instead of trying to break out of the frame, is you can hide a site can hide its own content. So if it detects it's being framed, it can prevent the user interacting with it. So the user can't click any buttons, and nothing bad can happen. You can see here, this is Twitter and Facebook. Both these sites have slightly different clickjacking protection. What Facebook does is it will put a semi-transparent overlay over a page if it's being framed, and when you click on that, it will try and frame bust. Twitter, on the other hand, it tries to frame bust all the time. If that doesn't work, there are various ways to prevent frame busting. It will just hide its content. Unfortunately, JavaScript protection isn't 100% effective. One method to prevent the site from frame busting is to use HTTP redirects to stop a page from loading, from busting out. This page tells you how to do that. And there's also various browsers